Hello again, everybody. This is our solution to problem 3 from Quiz 3, Spring 2023, Math 302 at Cal State Fullerton. And we're still looking at divisibility here. So this is a very straightforward problem where we're given three integers, x, y, and z. We know that the first integer x divides 3 times the second integer y, and also that x divides twice the third integer, z. And we want to prove that this means that x has to divide 15 times y minus 8 times z. And this is just going to come down to the definition of divisibility. Okay, and teeny little bit of algebra. So x dividing 3y, this tells us that there exists some integer, let's call it, I don't know, say little m. So I have some integer m such that 3 times y is equal to x times m. Okay, so it's just how divisibility works. And then x divides 2z, this tells me that there exists another integer, how about we'll call it little n, such that 2 times z is equal to x times n. And now we want to prove that x divides, well, this more complicated expression. And, well, what would this mean? So for this to be true, we would need to find, so there has to exist some integer p such that 15y minus 8z is equal to x times p. So if you like, I need to multiply x by something to get 15y minus 8z. All right, but let's compare what we have with what we know. Over here on the left, we have a 3y, and what we want actually, right, is 15y. Well, there's a connection between 3y and 15y, right? 15y is just 5 times 3y. So in fact, I know that 15y is equal to 5 times 3y, but 3y is xm, so this is equal to 5 times xm. And I'm going to rewrite this, right? I have commutativity and associativity, so I can basically put this in any order I like. I'm going to write it as x times 5m. And I'm going to play the same game with the z's. So here I have 2z, and I want to get something that's like an 8z, or maybe even a minus 8z. And so if I wanted to do minus 8z, well, minus 8 is negative 4 times 2. So this would be negative 4 times 2z. Or if I replace 2z with xn, this is negative 4 times xn. And I'll rewrite it again as x, and this time times negative 4n. Now, ultimately, I want 15y minus 8z, and, well, look at this. 15y minus 8z, so I'll just add these expressions together. 15y minus 8z is going to equal x times 5m minus x times negative 4n, or plus, excuse me, we're adding these. Okay, of course, I can factor an x out, and so I'll get x times 5m minus 4n. And because m and n are integers, when I multiply m by 5, I still get an integer. When I multiply n by 4, I still get an integer. And when I subtract an integer from an integer, I again get an integer. And so ultimately, I've written 15y minus 8z as equal to x times some integer. So this is my p. I don't have to write p equals this or anything, right? But this is my p, 5m minus 4n. So this implies 15y minus 8z equals x times 5m minus 4n, where 5m minus 4n is an integer, and this implies that x divides 15y minus 8z. And there we go. All right, we'll see everybody next time.